Okay, so today we're going to take a look at a couple of sample problems that we have for our online homework. Your numbers may vary. They might somehow be the same as mine, but very unlikely. That being said, this will show you kind of how to solve some of the problems. Hopefully you've gotten through at least some of them. I choose a few of them each time and try and do some videos to help support with them. So the main ones that we're going to take a look at today deal with density. So the first one we're going to look at says the following. Copper rod has a height of 3.2 centimeters and a mass of, there's an odd string of numbers. I believe I'm starting to program these in, and so you might actually end up with 6 decimal places. I'm still learning everything that I need to in the programming. So mine says the following. I've got a copper rod. So I didn't specify per se, but it's a cylindrical rod, just like the ones that we looked at in class. And it's copper. And the height, h, is equal to 3.2 centimeters. And it has a mass, m, equal to 545.224 for mine. I'm going to call that 445 grams. Now, you're welcome to include the additional numbers in there. I apologize. That's coming from me learning the basics. I think I got that figured out, but we'll see in the long terms, or long term if I actually did. That being said, for our problems, as long as you're within 3 significant figures, if you keep things to 3 significant figures, you should be in good shape. I believe on this one, you need to be within 2% of the accepted value of basically what it's supposed to find. So as long as you're keeping 3 significant figures, you'll be within that. You should be good. All right. So technically mine is 545.224, but 545 to 3 significant figures sounds great. The density of copper. So we are given that the density of copper, and this should be the real value, is 8.96 grams per cubic centimeter. All right. Now, the final thing that is asked is, what is the radius of the rod? Now, this is one that's a little bit different from what we've done in class. If you take a look at your notes, this is stuff that we have done, but usually we had the radius and we were finding something else. In short, what we want is the following. Okay, well, we can set up one of the big equations that we actually know. We know that the density, rho, is equal to the mass divided by the volume. Okay, so one of the first things that we can do is actually go through and find the volume. I can fill in things that I know. I know that the density is 8.96 grams per cubic centimeter. And that, according to this equation, this is my rho, my density, will be equal to the mass, which we said was 545 grams, 545 grams, divided by whatever the volume happens to be. So let's go through, and as step number 1, let's find the volume. The volume will be equal to, oh, I'm getting ahead of myself. I want to solve for the volume, so let's get it out of the denominator. I'm going to multiply both sides by the volume. That gets it out of the denominator on the right and over into the numerator on the left. But I want it by itself, so I'm going to divide by 8.96 grams per cubic centimeter. So I'm going to divide by 8.96 grams per cubic centimeter. I can move things around in an equation, but whatever I do to one side, I have to do to the other so that it will stay equal. I can't just change one without changing the other. All right. Now, the nice thing about this is it's going to cancel that out, and we're left with V by itself. So I get the following. That V equals 545 grams divided by our density, 8.96 grams per cubic centimeter. Now, one of the things that I want you to notice is the grams cancel out. When we have 1 over cubic centimeters in the denominator, a little bit of math, that will actually flip back up into the numerator. So we're going to end up with cubic centimeters. All right, 545 divided by 8.96. I get that the volume should be very close to 60.83, so I can call it 60.8. 1 over cubic centimeters. The cubic centimeters actually flip back up into the numerator, and we end up with cubic centimeters, which is the right units for a volume. Great. Now, because I want the radius, let's bring in something that we worked with in class. The volume for a cylinder is equal to pi r squared times h. Well, let's fill in what we know. We know that the volume is 60.8 cubic centimeters, and that is equal to pi times radius squared times our height, which I believe was 3.2. Smartboard. 3.2. 3.2 centimeters. I want to solve for r squared, so I'm going to divide. Let's divide by pi. That's going to cancel that out. And divide by 3.2 centimeters. That's going to cancel that out, leaving r squared by itself. I'm going to divide by pi and 3.2 centimeters. Technically, they're multiplied. This leaves me with r by itself. Well, I'm sorry, r squared. R squared is going to be equal to 60.8 cubic centimeters divided by pi times 3.2 centimeters. Now, real quick with our units, pi has no units. We have centimeters here. That's going to cancel out one of the centimeters, leaving us with centimeters squared. Now I take 60.8. I still have it in my calculator here. I'm going to divide it by 3.2. Great, that gives me about 19. And I'm going to divide that by pi. So I'm basically taking 60.8 divided by pi and divided by 3.2. And I get that r squared equals 6.05 centimeters squared. Remember, one of them got canceled out by that. Now I want r, so my last step is going to be, I don't want r squared, I need to get rid of that squared, so I'm going to take the square root. This leaves me with r equals the square root of 6.05, and my calculator is telling me that that should come up to 2.46. I have 2.459. If I round that to three significant figures, I get 2.46. And I had centimeters squared, but I took a square root. Whatever I do happens to the units as well. This becomes centimeters. The radius of the rod should be 2.46 centimeters. Let's double check our answer. 2.46 centimeters is exactly what they have listed for it. So this is how you would go about doing that sort of problem. It's a bit different than what we did in class, but this is something that I do often. What we want to do is not just be able to replicate what we do in class, but to be able to work with the relationships and work with the math so that we can predict other things.